Since its introduction 3 decades ago, the helicopter has been a valuable national asset. More recently, the Tiltrotor aircraft has demonstrated it can do almost everything the helicopter does and more, including flying like a fixed-wing plane once airborne. As our airports and airspace become more congested and the demand for short-range commuter flights grows, the appeal of rotorcraft is becoming greater. But current systems are too noisy, burn too much fuel, and require expensive maintenance. It is problems like these which NASA's Ames Research Center in Mountain View, California is studying. Here, engineers use wind tunnels to carry out aerodynamic tests, similar to those done on conventional planes and automobiles. A rotor blade section is mounted in front of a sophisticated instrument called a laser velocimeter, or LV. Once setup is complete, air, along with a fine oil mist, is blown through the tunnel. The tiny oil particles reflect light back into the LV, allowing researchers to determine how fast air flows around any area of the blade being tested. Related work is underway at the Ames Outdoor Aerodynamic Research Facility. In this particular study, engineers are investigating how certain aerodynamic characteristics of rotor systems influence overall performance. According to the chief of the Rotary Wing Aeromechanics branch at Ames, 10% of a rotor system's total energy is wasted because downward forces generated by the spinning blades push other parts of the aircraft towards the ground. Bill Warnbrook.
Consequently, the rotor system has to work 10% harder to develop an equivalent amount of lift, say to lift a crew and useful cargo.
Complementing these experimental studies are computer simulations. When a blade rotates, it is constantly colliding with tornado-like pockets of turbulence created by other blades in front of it. The result is less efficiency and greater noise. Simulations like these cut costs by allowing researchers to study aerodynamic problems before building the final aircraft. NASA's rotorcraft research, an approach aimed at improving the performance of future transport systems.